Hello class, we're back again, and I just wanted to go over another plotting of a rational function, but in this case our rational function has an overall degree of 1, so we'll have a little bit of long division to do in this one. So as we start off and work through this, our first step again is to find our vertical asymptotes. So that means we want to just factor or solve for the denominator, and in this case it's a nice easy denominator to work with. You just have to set x plus 1 equal to 0, and you find out quite quickly that x equals -1, so we'll draw our asymptote there and make sure you label it. And now we will solve our numerator to find our zeros. So in that case we have x squared minus 9 is equal to 0, so you could quickly see that that is going to factor into x plus 3 and x minus 3, which will give us x equals -3 and x equals 3. So we'll plot those. So we're at 3 we have a 0, and at -3 we have a 0. So plot those. And now we're on to determining what our overall degree is. And in this case, our overall degree is equal to 1, so that means we have a little bit of long division to do. So in long division, remember we're x squared minus 9 divided by x plus 1. So we're going to multiply the factor x, the linear term x plus 1 by x, and that's going to give us x squared plus 1. So when we subtract that term, we're going to get the x squareds are going to cancel, but then we're going to have negative x in the bottom, and remember to bring down that -9. So now we've got to find the next term, and that's going to be -1. So that will give us I'm just going to change the ink color so we can see it better. That'll give us negative x minus 1, and when we subtract that quantity, we're going to get 0 minus 8. So we really don't care about the -8. That's just going to be part of our remainder, but the real thing we're interested in is what our equation of the slant asymptote would be, and that would be y equals x minus 1. So when we plot that, we have a y-intercept of -1, and we have a slope of 1 for this. So we're going to go up 1 over 1, up 1 over 1 as we draw a few points in so we can accurately draw our dotted line to show our asymptote. So now we're going to draw a table, and we're going to use some test points to figure out what's going on with this function. So remember in the last video we talked about having different zones for plotting and also finding our y-intercept. So the first thing would be in step 4, we would want to just find out what our y-intercept is. So that would mean finding what f of 0 is. So when we plug in 0 in this function, you find out that you get 0 squared minus 9 over 0 minus or plus 1, which is just going to be -9. So that tells us that when we're at x equals 0, we're going to have a point down here at 9. Let me just make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me change that. That will be our point 0, comma -9. I'll extend my asymptote so that I make sure to keep that in mind. And now I'm going to construct a table because I have two zones I really am interested in determining where my curve is going. And I actually think I have enough data here on the right side in zone 2 to plot. Oh, I'm going to miss that point. That's why we want to use a pencil when we do this type of plotting, because we want to get the curve just right. Let me extend this asymptote. And remember, in the long term, the function, or in the long run, the function is going to try to reach that asymptote and behave just like that asymptote. So it's going to have the end behavior of this function y equals x plus 1. That's what we discussed with the slanted asymptote in class. So that's going to be our right side of the function, zone 1. In zone 2, I have one point right here, a 0, and I kind of have the feeling that it's going to be symmetric, and it's going to do this, but it would be nice to have another test point just to verify that. So I think what I'm going to do is I'm going to plot a point at x equals -2 just to check that out. So I'll do that real quick. So this will be my test point, f of -2. So I'll have -2, that'll be squared. I'm following this function rule, over -2 plus 1, and that'll be 4 minus 9 over -1, which will end up being 5. So that tells me that when I'm at 2, my suspicions were correct. Let me just show the point. When I'm at -2, my y value is 5. So I'm going to plot that point at -2. -2, comma 5. 1, 2, 3, 4, 5. So look at that. Right on the money. There's my curve. And this is what the function would look like with slanted asymptotes for x squared minus 9 all over x plus 1. I hope this short video helped remind you of a few of the key points that we did in class. Remember, one of the things that I really didn't explain during class was, because we weren't at the point yet for graphing them, was that when we get all of our asymptotes drawn and our zeros plotted and we have our test points, it's really good to consider breaking your graph up into zones and then plotting test points within those zones to see where they fall with respect to the asymptotes. Hopefully this has helped you, and look forward to hearing from you in the future.